Today we continue with our survey of the fascinating rocks from the Quarry Site location northeast of Rock River, Wyoming, focusing on unique Jasper nodules which are found in abundance both loose on the ground and in situ in their limestone host rock. These specimens showing them clustered in the limestone are just amazing collection pieces. The formation of these Jasper nodules in the limestone is a complex process that involves the dissolution and replacement of limestone with silica, coming from either an abundance of diatoms and other microscopic sea creatures that have silica exoskeletons that are deposited within the limestone itself, or perhaps originating from overlying or underlying rock layers, such as plutonic intrusions that may come in from below, and or maybe overlying volcanic ash, just as a few examples. Silica dissolved in water and percolating through the rock is redeposited in voids and cavities within limestone. Remember that limestone easily dissolves in acidic water and often has such cavities and voids, which is what leads to the world-famous cave systems we have heard of, almost always being in limestone. Iron oxides and other impurities that are also in the water give the jasper its bright colors, usually reds and browns. These voids could have been pre-existing, or the replacement can occur simultaneously, in which case, as the limestone dissolves, it is replaced with silica at the same rate so that a void never really exists. Just looking at these rocks, though, shows how complex this process can be. For example, how do we end up with a round concentric nodule that appears to be layered, and yet the center core is still limestone? Seeing these in the host rock reveals so much about them. You can clearly see how much harder the jasper is than the limestone, as is evidenced by how they protrude from it. Also, these miniature clusters kind of give us a perspective of how they distribute themselves through the limestone. The larger ones form similarly, just on a much larger scale. Since the limestone dissolves away with just water over time, and the jasper won't erode at all unless physical mechanical erosion of the rock takes place, such as by rushing water in a river, rolling the rock along, or wind-blown sand, converting it into a ventifact. Another interesting occurrence we find is that since fossils such as corals and shells form inconsistencies within the otherwise solid limestone, these often provide perfect places for the silica-rich groundwater to move through, dissolving away limestone while simultaneously depositing silica, such as this layer of shell imprints perfectly preserved in jasper. You may be familiar with Wyoming's Turritella agate, where a thick layer of snail shells also provided such a place that groundwater could move through. That agate, however, was formed in a lake bed on an intermountain plain about 50 million years ago amongst the recently formed Rocky Mountains, and not in a marine environment where these limestones and the nodules that are the subject of this video were formed. But the process was similar. Our limestones are much older, having formed from the Cretaceous interior seaway. Yes, this part of Wyoming was an ocean, considered to be quite shallow, however. In the area where these nodules are collected, there are occasionally seen beds of sandstone, such as in this photo where sandstone is overlying the limestone. This all took place, according to geologists, some 300 million years ago. Even though my friend Grant and I made the trek out to this location so many times over the years, I never got tired of picking up at least one or two of these nodules each time, especially since they are found relatively close to where we parked the car compared to some of the other collectibles, which were at least a couple of miles further away. It seemed that there was always a new pattern or structure within the limestone that we hadn't seen before. I hope you have enjoyed these and that you will keep up with this new playlist, as there are many more treasures yet to be added, including banded agate geodes, lapidary grade jaspers, rose quartz, hornblende schist exhibiting fine crystal clusters, petrified wood, and others. And please remember to like and share, as that really helps out the channel, and we look forward to seeing you on the next one.